Name of this project is Automation of Water Treatment Plant using Raspberry Pi. Clean drinking water is a basic human need. Water treatment plant transforms the raw water into potable water by using appropriate treatment processes. Automation serves a vital role in safe and reliable operation of water treatment plant in providing safe drinking water. Automation of water treatment plant has already been developed and widely used in many countries, but most of them use programmable logic controllers, that is PLC. This project focuses on an innovative and intelligent control and monitoring system for water treatment plant by using Raspberry Pi for the automation of small water treatment plant. Basically, there are few stages involved in water purification. First one is coagulation, then flocculation, sedimentation, filtration and disinfection. These stages are implemented in water treatment plant. This is the GUI, that is graphical user interface of water treatment plant. Now we'll see the block diagram of this system. I am using Raspberry Pi for the automation. Raspberry Pi is a mini computer. We'll see the block diagram of a system. Basically, automation involves the monitoring of few sensors such as turbidity, flow meter, level sensors and differential pressure sensors. These sensors has output of 4 to 20 milliampere, which is then converted into 0 to 5 volts. Then it is connected to ADC, that is MCP3208, and it works on SPI protocol. So this ADC is communicating with Raspberry Pi using SPI protocol. Similarly, automation involves a controlling of few digital outputs such as flash mixer, clariflocculator, dosing pump, valves such as inlet valve, outlet valve, backwash valve, drain valve and air blower. These digital outputs are connected to a IO expander MCP23008, and it is communicating with Raspberry Pi using I2C protocol. Now we'll see the model of water treatment plant and actual system. This is model of water treatment plant. First one is aeration fountain, then flash mixer, then clariflocculator and filter bed. So at various points we'll measure turbidity of a raw water, settling water and pure water. So here we are measuring turbidity of raw water, then settled water, and then at the end we'll measure turbidity of pure water. Output of this turbidity sensors is 4 to 20 milliampere. At the same time we'll measure flow rate of incoming water using flow meter, which is having 4 to 20 milliampere output. Now we'll see the interfacing circuit and Raspberry Pi. This is Raspberry Pi. It's a mini computer, so I have connected 10-inch LCD to a Raspberry Pi, and through USB hub I have connected USB mouse and USB keyboard to a Raspberry Pi. It had some GPIOs, that is general purpose input output pins, through which I have interfaced few sensors, that is turbidity, flow meter, differential pressure, and controlling few digital outputs. I have designed a GUI, that is graphical user interface, using Python and tkinter programming language. As you can see in the here in the screen, there are 3 stages: stage 1, stage 2 and stage 3. If I click on the stage 1 button, it involves aeration fountain and turbidity of a raw water and flow rate of a incoming water. Here you can monitor turbidity of a raw water, turbidity of raw water, flow meter, flow rate and differential pressure. Now my threshold value for a flow rate, that is incoming water, is 2000 meter per second. If the incoming flow rate of a water is greater than threshold value of a flow rate, it signifies that water is coming to a water treatment plant and my process of water purification should start. Now using this pot, I am generating 4 to 20 milliampere output. Now I'll increase a flow rate using this pot. You can see the change in the value on GUI. As you can see, flow rate is increasing slowly. Now flow rate is 13271464. My threshold value is 2000. If this value is greater than 2000, my process should start. Now you can see here value is greater than 2000 meter per second and process has been started. Here now raw water is drawn from a river. It enters into a aeration fountain where oxygen is dissolved into water. Then it enters into a flash mixer. At this stage, alum is added to a water as a coagulant. Then it enters into a clariflocculator and then filter bed. Here you can see status of alum dosing pump. It is switched on, inlet valve is on and outlet valve is on. You can see the status of these parameters on GUI also. If you click on the stage 2, you can see flash mixer. If it is on, it will show 1. If it is off, it will show 0. Here currently it is showing 1, that means flash mixer is on. Then clariflocculator is also on and alum dosing is on. Similarly, in stage 3, you can see the status of inlet valve and outlet valve as 1, 1 and all other valves are closed. So 0, 0. Blower is also off. Here you can also measure or monitor the turbidity of pure water in stage 3, and at stage 2 you can monitor turbidity of a settling water.